Your chemistry Miss Mrs. Anbumala. Today we are going to see the topic stochiometry. So what is mean by stochiometry? Stochio means element, metron means measure. Okay. So first we are going to see the how to understand the stochiometry. So first we take 1 cup rava and 2 cup sugar and half cup ghee, and another one is half of nuts to give 6 cup kesari. Okay, so you understand this concept, and again another one more example. See that example. So that is 1 cup of milk, then 10 gram of coffee powder and 10 gram of sugar. Okay, so 1 cup of milk, 10 gram of coffee powder, 10 gram of sugar. So now we are preparing 1 cup of coffee. We need 1 cup of milk plus 2 gram coffee powder and 2 gram sugar. 2 gram sugar. So how many number of coffee we prepared? That is only one cup of coffee only we prepared. What is the meaning for that? Here 1 cup of milk only we are taken. 1 cup of milk, 2 gram of coffee powder, but 2 gram of sugar for preparing for 1 cup of milk. But here that is the 1 cup of milk is the determine the coffee. So that is the 10 gram out of 10 gram of coffee powder, remaining 8 gram of coffee powder is remaining and 8 gram of sugar will be remaining. But 1 cup of milk is determine the rate of the reaction. So that is called as stochiometry. So that is 1 cup of milk is the rate determining step. So that is the 1 cup of milk only determine the number of coffee. So not the coffee powder and the sugar. So that is 1 cup of milk we need for this. So that is the reason 1 cup of rava, 2 cup sugar and half of ghee and call cup nuts to prepare 6 cup of kesari. We need for 12 cup of kesari means that is we need the 2 cup of rava. So that is 2 cup of rava will converted 12 cup kesari. So that is the increase the number of rava. So that is the cup of rava will determine the number of cup of kesari. So that is the 1 cup of rava we prepare need increase the 2 cup of rava, it will give the 6 cup of kesari. Okay, so we now understand the next this concept, we understand the another one. So okay, what is then another one? What is mean by stochiometry? Stochiometry gives the numerical relationship between chemical quantities in a balanced chemical equation. So what is mean by stochiometry? So the stochiometry mean by calculate only the chemical quantities and the balanced chemical equation. So here that is one example, carbon plus carbon plus one carbon is solid carbon plus oxygen and the carbon dioxide. So 1 mole of carbon and 1 mole of oxygen to give 1 mole of carbon dioxide. So 1 mole of carbon is equal to the 1 mole of oxygen equal to this, that is the triple line is indicate is a similar equation. So similar stochiometry equation, it is equal 1 mole of carbon, 1 mole of oxygen and 1 mole of carbon dioxide. So that is the equal. So next we are going to see the one example how to calculate the stochiometry. So stochiometry, first we are understand the what is the relationship between the reactant and the product in a balanced chemical equation in moles. So what is the reaction between the reactant and the mole? First we are going to see the what is mean by reactant. So here what are the reactant between the reactant product and the balanced equation in moles. So this is expressed in moles and the mass units. Okay, so before going to understand what is mean by reactant. So what is mean by reactant? The left hand side is called as reactant, that is the carbon and oxygen is reactant and carbon dioxide is the product. Okay, so this is the reactant and the product. What is mean by reactant? The left hand side is reactant, carbon and oxygen is reactant or carbon dioxide is the product. Next we are going to see the first one is what is mean by mass. So here they express in mole mass unit. So this relationship between reactant and converted into product, it is expressed in the stoichiometry calculation. First we are going to understand what is mean by mass and what is mean by volume. Okay, so that is the mass unit volume. So here that is mass equal to divided by mass. How to calculate the number of moles. What is n? N is equal to mass by molar mass. What is n? Number of moles. How to calculate mass by molar mass? Mass by molar mass. So how many number of mass will given? That is molar mass of the given element. So that is mass is converted into number of moles. N is equal to mass by molar mass. Okay, so this is the another one, mass by molar mass. So next one is so here that is the reason mass divided by molar mass equal to number of moles. Next we are going to see number of moles is converted into volume. So how to convert it into volume? One volume is occupied by 22.4 liters. So that is n is equal to n multiply 22.4 liter, that is equal to the volume. So that is number of mass is given, converted into number of moles is divided by molar mass, that is n. N is equal to mass by molar mass, and then multiply by 22.4 liter. Number of moles is converted into volume means multiply by 22.4 liters. Again another one, how to convert the volume. So volume is back to this number of moles. Volume is converted into number of moles means it is divided by 22.4 liters. Okay, so again number of moles is converted by mass means that is multiplied by molar mass. Okay, so this is the mass number of moles volume relation. Mass can be converted in number of moles, so number of moles is converted into volume. So next example, that is methane. Methane when burned with oxygen. So methane is burned with oxygen. This is the methane burned with oxygen to liberate carbon dioxide. This is 1 mole of methane, 2 mole of oxygen is react with the produced 1 mole of carbon dioxide and 2 mole of water. How to calculate the stoichiometry number of moles? So this is again I write the equation. What are the content? Methane, oxygen is the reactant and the carbon dioxide and water is the product, right? So how to calculate the stoichiometry coefficient? So what is mean by coefficient? So CH being before the CH only one is understood, that is CH4 only one, and that is we write here, that is oxygen contain 2, that is 2 coefficient, the carbon dioxide only 1, again water is contain 2. Okay, so this is the another one. So next one, the CH4. What is the molecular mass of CH4? How to calculate the molecular mass of molar mass or molecular mass of CH4? That is the stoichiometry, 1 mole. So 1 mole of methane and 2 mole, that is it is converted into 1 mole and 2 mole, then 1 mole of methane and 2 mole of oxygen and 1 mole of carbon dioxide. So that is how to convert it into a mole in a number of mass relationship. Before going to that, first you have to calculate the molecular mass of methane. So I have to calculate the molecular, how to calculate the molecular mass of methane. So I am writing here, that is 1 mole. So how to calculate the molecular mass? CH4 first. CH4, carbon atomic molecular mass 12 plus hydrogen 4, that is equal to 16. Oxygen is equal to 16 into 2, so that is 32. Then carbon dioxide, carbon is 12 plus oxygen is 16, 2 multiply 16, that is 32 equal to 44, that is carbon dioxide. Water we already know that is 18. So 2 plus 16 equal to 80. Okay, this is the molecular mass of this given compound, reactant and the product. Now that is the what is the mass relation. Methane is 16, so oxygen is 32 and carbon dioxide. How to calculate mass relationship? 1 mole is equal to, so that is 1 mole into 16 gram mole. So that is 1 multiply 16, that is methane molecular mass, that is 16 gram. Then oxygen is, then 1 mole into 16, that is 16 gram. Then 2 mole 32, that is 64 gram. Then carbon dioxide 1 mole multiply 44, 2 mole multiply 18, that is 36 gram. Okay, so this is the another one. So next one is mass reactant. So how to calculate mass reactant? That is also mass is equal to mole into molar mass, reactant and the volume of the product. Already we are calculating that one. So that is the same thing we can write here. That is 16 grams, 64 gram, 44 and the 8 gram. So next we are going to calculate volume relationship. We are how to calculate volume? Number of moles multiplied by volume 22.4 liter, that is number of moles how much, that is 1 multiply 22.4, that is number of moles 2 here, that is 22.4, here 1, that is 22.4, here 2 mole, that is 22.4 here, right? Okay, so that is we can calculate, that is the 22 point here, that is the same number of moles is converted into volume, means you can multiply by 22.4, that is the another one, again it will converted, it is multiplied. So this is the stoichiometry calculation. Next we are going to see the problem already given in your textbook. So this is the first one. First problem. So this is the first one, is a number of moles calculation. So number of moles, how many moles of hydrogen is required to produce 10 moles of ammonia. So here the question is 10 moles of ammonia, and how many number of moles of hydrogen we need to produce 10 moles of ammonia. Here now balancing the equation, write the stoichiometric equation. Nitrogen, 1 mole of nitrogen, 3 mole of hydrogen. To balancing the equation, here 2 nitrogen is there, so that is here 2 mole of hydrogen, that is 3, that is hydrogen 6, totally 6 hydrogen, right? So 6 hydrogen, so 2 mole of hydrogen need 3 moles of hydrogen, we need 10 moles of ammonia. So 2 moles of ammonia. So how to write? So here 2 moles of ammonia, this is ammonia, 2 moles of ammonia need 2 moles of ammonia required 3 moles of hydrogen. How much amount of hydrogen we need? So that is the hydrogen we need. The 2 moles of ammonia required 3 moles of hydrogen. Okay, so here that is 3 moles of hydrogen. 2 moles of ammonia required 3 moles of hydrogen. Then so 10 moles of ammonia required how much? 10 moles of ammonia required how much? 10 moles of ammonia required how much? That is 2 moles of ammonia, that is 2 moles of NH3 requires 3 moles of hydrogen. A simple thing you can write like this, 3 moles of hydrogen. So 10 moles of ammonia required how much? 10 moles of ammonia required how much? Required how much? So that is just we say that this is X, we can write like this, cross multiplying this one, you can calculate simply a simple calculation. X cross multiplying like this, 2x equal to 10 into 3, so x is equal to 10 into 3 divided by 2 equal to 15 moles of 5 into 3 equal to 15 moles of hydrogen. So 10 moles of ammonia required, 15 moles of hydrogen. So this is the answer. So first one is the 10 moles of ammonia required, 2 moles of ammonia required, 3 moles of hydrogen. So 10 moles of ammonia required how much? This is the calculation. Just cross multiplying that one, you can easily, that is the 15 moles. So 2 moles, so cross multiplying x, that is 2 moles, we can take x, so that is 2x equal to, that is 15 moles of hydrogen. Okay, so the answer is 15 moles of hydrogen. So this is the answer, this is the another one, 15 moles of hydrogen. Okay, so next this is the another one. Next question, this is the number of mole relation, number of moles relation. Next one is number of moles and mass relation, moles, mass and relation. 2 moles of ammonia required, so this is the another one. So next one is mole and mass relation. Calculate the amount of water produced by combustion of 32 gram of methane. So here the calculate the amount of water produced by combustion of methane. So that is I am writing that equation, CH4O2 carbon dioxide, this is the balancing equation, H2O. So that is the another one. So how to first step, how much amount of combustion of methane. So what is the molecular formula of methane? 1 mole of methane produce 2 mole of hydrogen. produce 2 mole of hydrogen. So 1 mole of methane produced 2 mole of hydrogen, water molecule, 2 mole of water molecule. So 32 gram of, so this is the first step. 1 mole of methane produce 2 mole of water. So methane, what is the molecular mass of methane? 12, 4 equal to 16 gram. So what is the water molecule? Water molecule, that is 18. Okay, 1 mole of methane means that is 16 gram of methane produces 2 moles. So that 32 gram of methane. So here gram of methane here 32 gram of methane produce how much? So here that is the 16 gram of, here that is the 16 gram of methane. So instead of H2O we are writing methane and the 16 gram of water. So not 16 gram of water, that is 18. The 2 moles of water is there, that is 2 into 18 equal to 36. Okay, so here so 16 gram of methane of so here that is 1 mole of methane, so that is 16 gram. So water is 2 moles, so the 2 into 18, that is 32. So 16 gram of methane, not water. So 16 gram of methane required. Methane CH4, methane, that is 32 gram of water. So because 2 into 18, so here that is 36, 2 equal to 36. Okay, so that is 36 gram of water. So 32 gram of methane, how much? So just 16x is equal to 32 multiply 36 multiply 32. So x is equal to 36 multiply 32 divided by 16. Okay, equal to 72 gram of water. Okay, so this is the another one. First one is, so here that is 1 mole of methane, combustion of 32 gram of by 32 gram of methane, that is 1 mole of methane produced CO2 and H2O. So 1 mole of methane produces 2 moles of water. So according to that stoichiometric equation, 2 moles of water produced. So the molecular mass of methane 16 gram, water is 18, that is 2 moles of water is there. So that is 32 moles is there. So that is 36 gram of water. So 16 gram of methane required, 36 gram of methane. Okay, so therefore so the question is given 32 gram of methane required how much? Okay, 32 gram of methane required how much? So just cross multiplying this one, x is equal to, so that is 36 gram of water. Okay, here methane, that is water. So next one is 16x, you are just cross multiplying this, x equal to the 72 gram of water. Okay, so this is the another one. X is equal to 36, multiply 32 divided by 16, 16, 36 divided by this 32 divided by 16 equal to 72 gram of water. Okay, so this is the another one. So next one, this is mole relation, that is the mass, mole and mole concept. Next one is mass relationship. How to calculate the mass relationship? So again another one. Next question is, so calcium carbonate is produced, how much amount complete the heating on combustion? Calcium carbonate gives calcium oxide and carbon dioxide. This is the balanced stoichiometric equation. So calcium carbonate and calcium oxide and carbon dioxide, everything only 1 mole of calcium carbonate and 1 mole of calcium carbonate and heating produce 1 mole of carbon dioxide. 1 mole of carbon dioxide. So 50 gram of carbon dioxide produced. So 50 gram of calcium carbonate, heating how much? So that is calcium carbonate. What is the molecular mass of calcium? 40, carbon 12, oxygen 3 into 16. So that is 100. Calcium carbonate, the total molecular weight 40 plus 12 equal to 100 gram of calcium carbonate. Hundred gram of calcium carbonate. Okay, so how to 100 gram of calcium, 100 gram mole minus 1. So next step, so heated completely under standard condition. So that is the produce 50 gram of calcium carbonate is heated completely under standard condition. So standard what is meant by standard condition? At the STP value, at the STP standard temperature and pressure, 1 mole of carbon dioxide is occupied by 22.47 liter. At the STP value, the verb is 22.7 liter. 22.7 liter. So liter. So at the STP value means that is 22.4. Normal atmospheric pressure means that is 22.4. So 50 gram of calcium carbonate contain how much? Calcium on heating. So this is the question. So first we are writing 1 mole of carbon dioxide. So 100 gram of calcium carbonate contain 22.7 liters. So 50 gram of calcium carbonate contain how much? 7 liter. So 50 gram of calcium carbonate contain how much? Okay, so that is just cross multiplying that. So X is equal to 22.7 multiply 50 divided by 100. 50 divided by 100. Okay, so that is the simple one. So X is equal to 11.35 liters. So the volume is occupied by 11.35 liter. Okay, so this is the another one. Liter of carbon dioxide. Okay, this is the simple one. First one is calcium carbonate completely dissociate calcium oxide and carbon dioxide. Okay, so heating standard condition 1 mole of calcium carbonate. So 1 mole of calcium carbonate will produce 1 mole of carbon dioxide. So everything is 1 mole. 1 mole means that is calcium carbonate, 1 mole of calcium carbonate and heating 1 mole of carbon dioxide is produced. So that is the another one. Produced, that is calcium carbonate. So molecular mass of calcium carbonate is 100 gram. Calcium carbonate molecular mass 100 gram. So here that is again at the STP 1 mole of carbon dioxide occupies 22.7 liters. So 50 gram of calcium carbonate contain how much? So that is, it is simplify that you can obtain. So 11.35 liters of carbon dioxide. Just cross multiplying that one, you can obtain the value 11.35 liter of carbon dioxide. Okay, So next one, how much volume of chlorine is required to form 11.2 liter of HCl at 273 Kelvin and 1 atmospheric pressure? How much volume of chlorine is required to form 11.2 liter of HCl at 273 Kelvin and 1 atmospheric pressure? Okay, so at STP value, so here first you write hydrogen and chlorine to form hydrochloric acid. So 2 mole of hydrochloric acid required, 1 mole of chlorine gas. So here for formation of 2 mole of hydrochloric acid, we need 1 mole of chlorine gas. So this is the first step. So another 1 mole of chlorine gas. So here they are asking 11.2 liter of hydrochloric acid at 273 Kelvin. So how to calculate the first one? One mole equal to 22.7 liter. That is 1 mole is occupied by 22.4 liter. Upon 2 mole equal to 2 multiplied 22.4 liters. So equal to 44.8 liter. That is 2 mole. 1 mole occupied by 22.4 liter. So 2 mole is occupied by 44.2 liter. So 2 mole of HCl is required. 1 mole of chlorine gas. So here now we can calculate. So 1 mole is occupied by 22.4 liter. So 44.8 liter occupied by, that is 22.1 mole of chlorine gas required. So that is the 2 moles of hydrogen. So we required 1 mole of chlorine gas. So that is 11.2 liter of hydrochloric acid required. How much? So just cross multiplying that, x is equal to 22.4 liter, 11.2 divided by 4. So that is, you can see 44.8. So here is 2, that is only 1, again 2, that is 5.6. Okay, so this is the answer. So 5.6 liter of chlorine required. 5.6 liter of chlorine required. Okay, so this is the another one. This is simple one. So 1 mole of hydrochloric acid required to form. How much volume of chlorine is required to form 11.2 liter of hydrochloric acid at 273 Kelvin and 1 atmospheric pressure. So hydrogen plus chlorine give hydrochloric acid. So 2 mole of HCl is required to 1 mole of chlorine gas. So 1 mole is equal to 22.4 liter. That is 2 moles equal to 2 multiplied 22.4 liter. Then 44.8 liter of hydrochloric acid required, 22.4 liter of chlorine. So 22.11.212 liter of hydrochloric acid is how much? Okay, so this is the another one. So next one is, so just cross multiplying that, x is equal to, just you can answer is 5.6 liter. Okay. Okay, so after watching that video, you can write all these problem in your classwork. So what are the problem? First one is, you can write all these one. So calcium carbonate, that 4 problem is there. First one is mass ammonia, then methane, then this is ammonia. You can write like this one, and then another one is methane. This is the first one, second one, and third one, fourth one. So till the up to end, you can write in your classwork. Write it neatly. Don't scribble that. Okay. So this is that's all, children. Okay. Okay, you can write neatly in your classwork. This one. So 2 more problem is there. Okay. Thank you, children. Okay, see you the next video. Thank you, children. Bye.